sine, cosine, and tangent, and applying those ideas to some real-world situations. So our objective, the learner will use right triangle trig to solve real-world scenarios. So, vocabulary. Angles of elevation or depression. These are angles created by a person's line of sight to an object and their horizontal line of sight. Elevation means up and depression means down. So we're looking up and down at different things. So, angles of elevation. In the real world, trigonometry is used to measure very long distances, find the trajectory of a bullet at a crime scene, find the maximum incline for safety in ramps and roadways, measure the tides, navigate the oceans, and many, many other places. Problems in the real world solved with right triangle trigonometry commonly use angles of elevation and depression. So when I talked about the observer or the person's eye, here is your horizontal line of sight, so what you see when you look right out in front of you, and then how far up you have to look to see something, and we're measuring that angle from straight out, to up. Or if we're looking for angles of depression, what the angle is down to see whatever you're looking at. So this is looking up, and this is looking down. So, what steps do we need to take to solve real-world problems? So first, we have to read it a couple times. So we're going to read the problem to get a sense for the story. Are we looking up? Are we looking down? Do we know the angle? Do we know the distance? Get a sense of the story. Then we read it again. Marking the important information. Figure out what you have and what you need. Then we draw and label a diagram. We identify what information we still need and what has been provided or given, and determine which trig ratio to use, and then we set up the equation. Solve for the variable. Use a calculator to evaluate. The other piece that's new compared to this is that you have to write your answer in a complete sentence. But what was the number that you found? So let's look at these problems. So we're going to read it. The angle of elevation from point A to the top of a hill is 49 degrees. If point A is 400 feet from the base of the hill, how high is the hill? So I like to draw the picture first. So I have point A here, and then I have a mountain. There's my lovely mountain. And I know that this angle of elevation is 49 degrees. That's me looking up from point A to the top of the mountain. I also know that the bottom is 400 feet. So, how high is the hill? This is where having multiple colors might prove useful. So this is my opposite side, and this is kind of the side that I'm looking. This is my height. This would be the right angle. So this would be my hypotenuse. And then that would be the adjacent. So I have an adjacent side and an opposite side that I want and an angle. So if I have O and A, that's tangent. So tangent 49 equals O over 400. So we use our calculator. We multiply those things. So the opposite side is 400 times the tangent of 49, which is 460.1. Now, what does that number mean? The last direction or step was to write a complete sentence. So what is 461? You're going to take this last question and make it a sentence. The hill is 461 or 460.1 feet high. It's not a complicated sentence. It's just explaining what the number means in terms of the problem that you've been given. Let's look at number 2. From the top of a 120-foot high tower, an air traffic controller observes an airplane on the runway at an angle of depression of 19 degrees. So I have a 120-foot tower. I have an angle of depression, and I want to know how far from the base. So here's my tower. That's 120 feet. And we're going to, pretend I know how to draw an air traffic control tower. And the guy in the tower is looking down. But he's looking down at 19 degrees. And what I want to know is how far the airplane, don't laugh at my airplane, how far the airplane is from the tower. So a couple things about this. We talked about parallel lines. So the horizon here and the horizon here are parallel. And when we use a transversal to intersect those, this angle and this angle are congruent. So the angle of depression is congruent to the angle of elevation. So if this is 19, then this is 19. So now I have that this is the opposite side. Here's my right triangle. This is the hypotenuse, and this is opposite. So I'm using my opposite. I don't know why I wrote that as opposite. It's adjacent. So I have opposite and adjacent. That means that I have TOA. So the tangent of 19 equals 120 over x. So x equals 120 divided by tangent 19. We talked about that when x is in the denominator, you then divide the two numbers. So x is 348.5. Now, 3.485, what? What does that mean? So remember, we're going to turn this sentence into a question. The plane is 348.5. Everything was measured in feet. So feet from the tower. Your number has to make sense in terms of the problem. Number 3, a boat is approaching a cliff from a lighthouse with a lighthouse on the top. So we already know that the boat's in the water and the lighthouse is on a cliff. The cliff is 100 meters high, the lighthouse is 30 meters tall. The angle of elevation from the boat to the top of the lighthouse is 20 degrees. Calculate the distance to the base of a cliff. So we can almost start by drawing a triangle and then making our story fit. So here's the cliff, which is 100 meters high. And then the lighthouse which is another 30 meters tall. The angle of elevation from the boat up is 20 degrees. Calculate the distance of the boat to the base of the cliff. That means this is my x. So notice that I made the problem fit my right triangle. That's what we need to do. It has to fit a right triangle. And so we're trying to make that work. So for this angle, this is opposite, this is hypotenuse, and this is adjacent. We're using opposite, and don't forget it's both pieces, and adjacent and tangent. So I'm using O and A, that's TOA, tangent 20 equals 130 over x. So x equals 130 divided by tangent 20, which comes out to 357.2. So what does that mean? The distance from the boat to the base of the cliff. The boat is 357.2 meters. All of our units were in meters. From the cliff. So we can start each problem with a right triangle, and then we just draw the story to fit so that we can label the sides. and go from there. A pilot in a helicopter spots a landing pad below. We already know he's up and the pad's down. If the angle of depression is 73 degrees and the horizontal distance to the pad is 1,200 feet, what is the altitude of the helicopter? Altitude means height. So again, here's my right triangle. We're going to make this story fit this. So here's my helicopter. Don't laugh. And here's the landing pad. It has a big X on it. And I know that the angle of depression, so this angle is 73 degrees. That means this angle is 73 degrees. And the horizontal distance is 1,200. Horizontal is this side. And what I'm looking for is what is the altitude of the helicopter. So this is opposite. That's the X that I need. This is my hypotenuse, and this is adjacent. I have opposite and adjacent and an angle. So O and A, TOA, tangent 73 equals X over 1,200. This time X is in the numerator. So when X is in the numerator, we multiply. So that means that X equals tan 73 times 1,200, which is 3,925. But what is 3,925? That better be the altitude of the helicopter. So the altitude of the helicopter is 3,925 feet. So your answer needs to make sense. If you're 1,200 feet, that's 4 football fields. If you're 4 football fields away from a landing pad and you're looking down pretty steep, almost straight down, not quite, but almost, you better be pretty high. If we got a number like 2, that would be incorrect. So remember, we've talked about, does your answer make sense? Is it reasonable? So make sure that you can find that. All right, one more. The angle of elevation from a kicker's foot on a football field to the top of the goalpost is 17 degrees. So angle of elevation is 17 degrees. If she is standing 131 feet from the base, how tall is the goalpost? So here's my triangle. I can draw it either way, doesn't matter. But this would be my goalpost, right? Where we kick the ball through. And this would be the football. So this angle of elevation from her foot to the top of the goalpost is 17 degrees. She is standing 131 feet from a goalpost, and I want to know how tall the goalpost is. So here's my hypotenuse. Here's my opposite. This is adjacent. So we're working with opposite and adjacent and my angle. So I have O and A. That's TOA. Tangent 17 equals X over 131. x equals tangent 17 times 131, which is 40. What's 40? That better be how tall the goalpost is. So the goal, that's not how you spell goal. The goalpost is 40 feet tall. So I hope that you can see once you can make the problem fit the right triangle, it becomes much easier to solve. So for your summary, I want you to be able to list the steps to solve application problems. And anything you noticed in this section.